Hello guys, this is the first lesson of Virtual Summer School. I want to remind you that summer school is only gonna last 16 days. So I need you guys to do your best every day to make sure you complete the daily warm-up. That's for attendance. And that you complete, you watch the video lectures and that you complete the assignments. And this needs to be done every day, okay? Alright, so this first lesson is about adding and subtracting polynomial expressions. So I'm going to start to write down the objectives, and what I'm going to do is I'm going to work some problems, so this worksheet, and then I'm going to ask you to complete the rest and take a picture of what you did and then submit this picture on Schoology for a grade, and this needs to be done today. Alright, so the objective for today is so by the end of the lesson you will be able to add and subtract polynomial expression by combining like terms. Alright, so first of all, what's a polynomial? Well, let's start with monomial. Monomial is practically a term that is made up by variables like x and y and by coefficients that are just numbers. So polynomial means many terms. So just to give you an idea, if I have something like a 3x squared y, this is a monomial, because it's made up by the product of variables like x and y, and there is a number in front. There is no plus, there is no minus, so this is a monomial. Monomial means a single term, okay? But if I have something like a 3x squared y minus 5z, for example, then here I have the first term, that's a monomial. Negative 5z is another monomial, so that's the second term. And when you combine them with a plus or minus sign, all of these represent a polynomial, okay? So polynomial means many terms, okay? So you have many terms put together by a plus sign or a minus sign, okay? Alright, so and the goal for today is to be able to add and subtract polynomials by combining like terms. Okay, so let's start with this guided practice. So here we have a road sign that has a triangular shape, and we want to find the perimeter, okay? Alright, so recall from geometry that to find the perimeter of a triangle or any other shape, you always need to adapt the sides of this shape. In this case, we only have 3 sides. So if we want to find the perimeter, then this perimeter is the sum of this side, 5x plus 2, this side, and then this other side, which is 2x cubed plus 1. So let's add them up. We have 5x plus 2, that's one side. You can put in parentheses if you want, plus the second side, which is x cubed plus 5x squared minus x minus 2, plus the third side, which is 2x cubed plus 1. Now in this case, it doesn't matter if you put or not those parentheses because there is a plus sign, okay? If you had the minus sign, then they will become important, as I'm going to show you in the second example. Now notice that we have a single variable in this case, which is x. There is no y, there is no z, there is no other variables. Okay, so let's combine the terms. Let's start from the highest degree term, which is the x cubed. Do you see any other x cubed in this expression? Well, yes, there is a 2x cubed, so we can add them up. 1x cubed plus 2x cubed makes 3x cubed. And then let's go to the x squared term. underline this twice, there is only a 5x squared, so we need to write it down. We cannot combine. And then let's look at the x's term, underline this 3 times, 5x, here I have a negative x, and that's it. 5x minus x is 4x, so we're going to write it down. And then finally, I have a 2, I have a negative 2, and I have a plus 1. So I can combine this 2 with this negative 2 and plus 1. Now, 2 minus 2 is 0, plus 1 is going to be equal to 1, so we are left with this. Now, for your information, it is important you know this. The degree of a polynomial expression represents the highest, I'm sorry, this was a 3x cubed, I put an x squared, yeah. So the degree represents the highest exponent you see in the expression. So the highest exponent we see in this case is a 3, right? It's this one. So the degree is equal to 3. And then the leading coefficient, so let me write it down, this is the highest exponent. And then the leading coefficient is the number in front of the highest exponent term. So it's given by these 3 here because it's the number in front of this highest exponent term. So it's equal to 3. Okay? So in this case they coincide, but they don't have to coincide. Alright, so let's take a look at the second example. So here we have a minus sign. As I was saying earlier, you need to be careful with the negative sign. Negative sign means that there is a negative 1 hidden here, and therefore, in order to get rid of those parentheses, we need to use this distributive property. Now here in front of this parenthesis there is no sign, it means there is a positive, so there is still a 1, but it's positive, so when you multiply everything by 1, everything stays the same, right? So we can just drop this parenthesis and write this as 4x squared plus 7x cubed y squared. And now here I have a negative 1, so if you use this distributive property, negative 1 times negative 6 is plus 6x squared. Negative 1 times negative 7 is plus 7x cubed y squared. And negative 1 times negative 4x is positive 4x. So when you have a negative in front of parentheses, what you do practically is drop the parentheses and change the sign of these 3 terms. So this is positive, this becomes positive, this becomes positive. And the same for the last parenthesis. Negative 1 times 10x becomes negative 10x. And negative 1 times positive 9x squared becomes negative 9x squared. Now we combine the terms. Well, let's start with the x cubed y squared. We have 2 of those. 7 plus 7 is 14 x cubed y squared. Then we have a 4x squared, underline this twice, 6x squared minus 9 squared. So 4 plus 6 is 10. 10 minus 9 is 1. So 1x squared, or you can just write down x squared. If you want to put a 1, you can, but you can leave it as x squared. And then finally we have this 4x minus 10x. 4 minus 10 is negative 6, so this becomes negative 6x. Now, if you want to know in this case what's the degree and the leading coefficient, it's a little bit tricky because we have 2 variables, we have x and y. I put LC for leading coefficient. Well, the degree, you may guess is a 3 because there is an x cubed, but actually, since there is a y squared next to it, you add up these 2 exponents. 3 plus 2 would be 5, so the degree is 5. While the leading coefficient is the number of in front of the highest degree term, which is 14. Okay? Now, for this activity, you don't need to write down the degree of leading coefficient, even though I would appreciate if you try to figure out the degree of leading coefficient once you combine the terms, okay? So it's very important when we talk about graphing polynomial expressions, okay? That's the reason I'm showing you how to find the degree and leading coefficient. Alright, so for the dependent practice, I just want to show you 1 or 2 problems here. You should be fine for the first 3, okay? I don't see any difficulty with that, okay? And then be careful with number 4. Number 4 says if this quantity is subtracted from this, then the difference is what? Well, what if I say if 6 is subtracted from 10? Would you do 6 minus 10 or 10 minus 6? So if I say 6 is subtracted from 10, this means you need to do 10 minus 6. So in this case, how would you rewrite this expression? Okay, based on the hint I gave you. Okay, so if this is subtracted from this, which one are you going to write first? Okay, so think about it. If I say if 6 is subtracted from 10, I need to write 10 first, so I write 10 minus 6. Okay, and then this should help you out to combine the expression number 4. And then let me show you something like number 6. Okay, now number 5 you can just adapt. There is a plus, so just 2, 4, and 1x will be 7x, right? And then you do the rest. Okay, so combine these 3, combine these 2, combine these 3. Okay, and you do the rest. So for number 6 there is a minus here, so I need to subtract this quantity. Now when I subtract here 11 minus 5, this is going to give me 6m squared n squared. But be careful here, I have a 2mn and a negative 6mn. I need to subtract this. So what does it mean subtract? Means that 2 minus negative 6, okay? So here I'm working this right now, okay? So be careful with this. This is 2 minus, because there is a minus here, negative 6. But negative times negative makes this positive, right? So this is the same thing of 2 plus 6. So 2 plus 6 would be plus 8mn. And be careful for the last one. You have negative 11 plus 17, but there is a minus here. So it's going to be negative 11 minus plus 17, right? And negative times positive becomes negative. So it's the same on negative 11 minus 17, which is negative 28. So I practically work number 6 for you, but I want to make sure that you understand what to do when you have a negative sign. And then 7 and 8, well, let me set up for you number 8. You have the perimeter and you want to find this missing side, okay? So that's your goal. What if we add the numbers, okay? Let me draw another triangle here. Let's assume I say the perimeter, that's just an example, okay? If you understand what to do with numbers, it should be the same with expression. The perimeter is 10. Imagine I say this side is 2, this side is 3, so find this missing side. What would you do? Well, if the perimeter is 10, right, and you know that this side is 2 and 3, you know that the sum of these 3 sides must be 10, right? So you know that 2 plus 3 is equal 5, and therefore you can find this side. To find this side, you would just do what? 10 minus 5. So you adapt these two, right? You adapt these two, and you subtract them from 10. And then you know 10 minus 5 is 5. So let me write down here, 10 minus 5 is 5. So you will know that this missing side is 5, right? So use the same strategy here. You have the perimeter, which is the sum of these 3 sides. So what you can do is add up these 2 sides, so add them up and then subtract them from the perimeter. And you can do the same for number 7, okay? Again, be careful with number 10, okay? So this one is subtracted from this, okay? So make sure it's a similar, number 10 is similar to number 4, okay? It's the same concept, so you should be able to do that by yourself. And then using complete sentences and your own words, explain the process of adding and subtracting polynomial expressions. So you can just write down a sentence, 1 or 2 sentences here to explain this process. So if you have the opportunity to print this paper and complete the missing problems, then just take 1 or 2 pictures, okay, whatever you need, and submit into Schoology. If you don't have the opportunity to print this because you don't have a printer, then what you can do is just work the problems in a notebook paper and take a picture of your work and still submit on Schoology.